Hello all, welcome to my channel. I'm back with another video in the Airflow series. In this video, we will be discussing on different operators that we can use to run and Spark job using Airflow. So let's get started. So in big data world, s- Airflow has been a default orchestrator for running data pipelines and doing orchestration of different aspects of data pipelines or data engineering. It's just not the only choice. We have Temporal, we have Orchestra, we have different other tools as well. But Apache Airflow is one of the most widely adopted solution, and hence we are discussing that. So uh, to run an Spark job using Airflow, we need to have some sort of operator uh, which interacts with different external systems because we can host Spark on any multiple different distributed systems. Like it can be hosted on Yarn, it can be hosted on Kubernetes, it can be hosted on Databricks, it can be hosted on Spark on Kubernetes. So there are different ways which we can run Spark clusters, and to orchestrate the workflow of data movement on those platforms using Airflow, we need different operators, and we have there are many native operators which are there, and there are some provider specific operators. For example, we have Spark Submit operator, Spark Kubernetes operator, Spark SQL operator to run specifically SQL queries. Then EMR offers an EMR add steps operator. Databricks has its own Databricks Submit Run operator. Then Dataproc, which is Google's engine, that is Dataproc Submit Job operator. So there are different operators, and each of those operators have some different values that we or different configurations that we need to pass, and then we can run these things in from Airflow. And the common thing between all these is that we need basically one hook which allows us to talk to these systems, and then using those hooks not using those hooks, but we create a connection object which will have the configurations for the different clusters that we need to pass. For example, let's say if we are using Kubernetes, we need to pass the TGT token, so that can be stored as a secret in connection details, like or extra arguments we can be stored like the TGT token or the Kerberos credentials. So that kind of stuff. For GCP, we need to create a GCP connection, which is nothing but project ID, its credentials, its IAM roles, and other stuff, service roles, sorry. And then with AWS also, we have AWS connection where we can store secrets, or based on the way we configured, it can be an IAM or a third-party identity providers as well. So there are different mechanisms. So there are different connections that we can create, and each connection is mapped to a hook. For example, we can have hooks for Databricks environment, hooks for GCP environment, hooks for AWS environment, and using those hooks, we interact with the APIs that are exposed by those providers, and we run the job using that operator. So let's see what are the operators that are available for us. Like Spark Submit, this is the most common one. So it allows us to run a Spark jobs using Airflow in an Yarn environment. So the definition basically is this, like we say that Spark Submit operator, we give a task ID name, we say the connection, like Spark default is a connection for the Spark cluster. It will have details like how we authenticate to the cluster, what is the master node, and then we provide name to the task. Then we mention the application, like which jar needs to be run, and if we need to pass any kind of arguments to that. So here we are passing dates, date timestamp, region as US to run this job as an argument, and then we have the jar, the actual jar that is, or other jars that are needed. For example, if we are using Postgres connection, so we can pass Postgres jar, or let's say we are using Kafka, so we can submit Kafka jars then as well. Then we pass on the conf, like what should be the number of cores, executors, and everything in the yarn memory. I mean, like in Spark dot properties format. And then we have driver memory, number of executors, executor cores, these kind of things, and we pass the environment region, and then it will run and Spark job for us. We can have also a sensor that keeps on monitoring the status of the task. Then we have Spark Kubernetes operator. This allows us to run Spark jobs on a Kubernetes environment using Airflow, and this in behind the scene it leverages the Spark operator. So the prerequisite is that we have to install a Spark on Kubernetes operator, which is a CRD. This is a different operator. Like this is not an Airflow operator. This is a Kubernetes operator. So CRD, and then we had need a Spark image that we want to use in this case. So how we create is we create a YAML file for this using this Kubernetes operator object that defines the Spark application, and we pass this application in the DAG saying that okay, it is the Spark Kubernetes operator task ID. We define whatever we want, and then we set trigger rule. These are different things, but these are optional. The basic thing is application file, which defines how to launch an application, what should be the configuration, everything, which namespace we want to launch, and Kubernetes connection ID. This is important because we are running Spark on Kubernetes, so we need to provide the Kubernetes connection. So in this case, we have created a Kubernetes connection called Kubernetes default, and then we use that in there. And then we can again we can monitor that sensors like sorry you can we can monitor the Spark job using the sensors to see when the job completes. So this is running a Spark on Kubernetes. Then we have Spark SQL operator. This is an extension of the Spark Submit operator, kind of, but it allows us to directly run SQL queries on a Spark cluster. We can think this like of this of a Spark. So if we run Spark, we have Spark Cell, we have PySpark Cell, we have Spark SQL. So this comes under that the same domain. Like we can directly run SQL queries. Here also we have Spark SQL operator. We say the name task, we provide the connection ID, and then we say what SQL we want to run, and we can also pass some other configuration. For example, if we want to have some other jars when the Spark gets launched. For example, here we are saying that okay, we want to work with Iceberg, so we are passing the Iceberg jar, and then we also passing the Iceberg extensions in the Spark SQL extensions. So this is how we run a Spark SQL operator. This as I was saying, there are different all there are different operators, but all those things will have something common. But is like the operator, then they will have a different hook. Like Spark operator works on Spark Submit hook, Spark Kubernetes operator works on Kubernetes hook, EMR add steps operators which works on AWS hook, and Databricks Submit operator which works on Databricks hook. We have Dataproc, so for Dataproc we will need a GCP hook, and for other systems, we will have that system specific. For example, I think DigitalOcean also had some hook that we can use to run Spark workloads in there. The EMR add steps operator is an operator which allows us to add a job step in the AWS EMR cluster. So for this, we have to have a running EMR cluster. We need to know the job flow ID of that particular cluster. So this is how we create this. So we say add an step where task ID, whatever name. So job flow ID, nothing but the cluster ID of the EMR, and then we say what should be the cluster state, like when we submit, either it should be waiting or in the running state, and then we should say add a step using the Airflow connection ID to be able to access. And this connection ID, whatever credentials we are using, should have the access to add a step permission in their file. And this is general configuration that we can use, like whether we want to continue, whether we want to run a jar or what mode we want to run, deploy mode, and every other configuration is passed in like this. So this is for AWS EMR. Then we have Databricks as submit run operator, which is nothing but an operator which allows us to create a job in Databricks and run that job. So it also follows the same strategy that it will have a hook that we need to create. We need to create a connection, and then using that connection, which is Databricks connection ID, we say Databricks default, and then we have to pass the information like Databricks some return operator, and then we pass this JSON, which is the cluster details, and that new cluster information is here, like what should be the Spark version, what should be the node type, whether we want to auto scale, what should be the Spark configurations, security mode, runtime engine, and everything. So for example, if we want photon, we can mention it here, and then task what needs to be run. For example, this is one file that we are trying to execute. It can also have a uh, it can also have a predefined sorry it can also run a Python file or a notebook file as well. And then there is another option as well in Databricks, which is called Databricks run job now, which is that okay, there is a job which is already defined in Databricks and we just want to execute. And we also can override certain parameters or configuration which are there for that particular job. So that is another option. And similarly, we have Dataproc submit job operator, which allows us to submit a job to Dataproc, which is a GCP product. Again, we need to create a connection of Google Cloud default type, which uses a Dataproc hook. Basically, this is not a hook. This is a part of a bigger hook, which is a GCP. So in that, we have an option of when we install the providers from GCP, we will get this hook, and we have to create a connection, and using that connection, we can run. So we say project ID, everything information we pass, and then we say run this job. So whatever configuration everything remains something similar to what other operators do, and run those jobs directly for us. And there is one more. So in when we see the default connection, we have two kinds of hook. Like one is Spark Connect hook, and other one is Spark Submit hook. So Spark Submit hook, when we use, we have a strict requirement that the place from where this Spark Submit is happening, we need to have the Spark client installed in the path so that the binary can be accessed by the system who is launching that job. But if we don't want that configuration to happen, if we want to have a light client server architecture, we can use Spark connection hook. What it allows us to, what we will do is we will have a cluster up and running. And on that particular cluster, we will launch an Spark Connect app. So the driver keeps on running, and we will expose an endpoint where we can directly submit our queries to run, and that becomes an easier option. It makes our deployment lightweight, so that the uh, image which is getting launched, which is launching this task, doesn't have to be have full Spark binary installed in that. So that is another one important thing to note. So this was it. Like we have discussed six different operators that can be used in Airflow to run a Spark job, and we can leverage these things to make our lives easier, to make the whole process of running a Spark job or orchestrating Spark jobs or multiple jobs very easy. And if we want, we can combine operators. We can write custom operator which have both functionality of, let's say, two different mechanisms that we have. For example, we can create one single Spark operator, and based on environment, it picks up whether it should be Databricks operator, it can be the Spark operator, or Spark on Kubernetes operator. So that also we can do. So yeah, that's it for this video. If you like, do share and support the channel. And that's it. Have a nice day. Thanks.